In the previous video, I talked about randomization and how it's used in experimental research designs. I also mentioned that it's not the same as random sampling and that the goal of randomization is to eliminate systematic differences in groups. Okay? And usually we use either coin toss or a die or cards to randomly assign participants to different groups. However, there are situations where random assignment may fail us. So let's say, for example, we decide to do a coin toss to decide how we're going to assign our participants. So let's say for the first participant, after our coin toss, no, we find out that okay, the participant will be assigned to the control group. And then for our next coin toss, we find out that okay, this participant will also be assigned to our control group. And then after the next ones, we realize that we end up with more participants in one group versus the other. Okay? So now that we have that, we see that there is a quite a big difference between the number of participants and the characteristics of the said participants. And if you think about it, it probably did not eliminate systematic differences among our groups because we have definitely all the triangles are in one group and not in the other. And so, whatever the results of the study are, they would not be representative of these two kinds of groups. So, what instead, we could use another technique, which we will discuss later on. But I'd like to also mention other things that we need to take into consideration where random assignment would probably not be the best option. So let's say, for example, you want to compare males and females in a certain characteristic. So let's say you want to make males and females watch a film and try to measure their reaction on that said film. Now, if you, like, let's say, use random assignment, it would not make sense because you are actually comparing two different sexes and so they should not be randomly assigned to two different groups. Instead, they should be assigned based on their existing biological sex. The same is true, let's say, if you want to do an experiment where you want to compare the behavior of people from two different age groups, say 15 and 18-year-old students. It would not make sense to randomly assign them because then you are comparing the difference between two age groups. Also, there are some studies where, let's say, you want to take into consideration these two things in a control and experimental condition. So I don't think it's possible for you to just flip a coin and decide, okay, for this study you are going to be male when in fact they are female, right? Or when you choose a card and you say, okay, for this study you are going to be a 15-year-old kid when in fact they're already 18 years old. So, nope, no randomization for those two. Another thing to consider is when you are trying to use participants from different affiliations. So let's say you're a teacher and you want to try out a new teaching method. And you recruited participants from two different sections. Now, sure, When you're designing your study, it's perfectly possible, sorry, it's perfectly possible to perform random assignment, right? So let's say in one method, you want to use games in teaching the lesson, whereas in the control group, you just want to use the normal lecture discussion method. Okay, so we're gonna gamify the classroom. Now, in randomization, what you're going to do is to toss coin, for example, each member of section A, and decide whether they go to the control and experimental group. And you probably have to do the same with section B. However, the problem there is it would not be very feasible for the students to change sections in the middle of the school year for an experiment. It would be very impractical and difficult on the part of both the student and the teacher. And so, very often, what happens in experiments like these is that the experimenter will just toss coin and decide which section gets to be the control group and which one gets to be the experimental group. So let's say I toss coin, okay, and I see that, okay, for this study, section A will be our experimental group. That's pretty much it. The same is also true if you are recruiting participants from two different schools, for example, CPC versus FAF. Now, definitely, you could randomly assign them and say some of the students from CPC will be control group, some will be experimental group. But in some cases, some research is saying, oh, it's pretty hard, especially if you're dealing with the same students from the same section in the same school. So sometimes what happens is that they just run the experiment on the whole class from that one group. Okay, so really you have to take into consideration what question are you trying to answer. Are you trying to compare two groups with two different characteristics, such as these, or whether it is too impractical to have to randomly assign your participants to two different groups, or if you are actually worried that you might end up with a lot more participants in one group versus the other. So, one way we try to solve this is by matching our participants. So, this is used in cases when participants cannot be randomly assigned to conditions. And how we do it is we simply match participants on relevant background variables and discard those without a match. So, what we usually do in cases like that is let's say sorry. So, let's say we have two groups. Okay, and so we have our control group and we have our experimental group. And so we have a mix of participants. So we have so we have a mix of triangles and stars. Okay. So we are not going to toss coin each of them. What we're going to do instead is we are going to pair them up based on their characteristics. So let's say we want to take into consideration, so let's say this is sex. So the triangles are males and then the stars are female. So we want to make sure that we have pretty much equivalent set of students for each group. What we could do then is that arrange them or pair them up. So let's say you have your two females here. Okay, so what we can do then is toss coin for the first one. Okay, and then when the results show, the toss coin show that, oh, the person is assigned to the control group, then automatically the next person is assigned to the experimental group. And then let's say let's toss coin the two males, and then okay, so toss coin, and then this person goes to this group, the other person goes to the control group. Okay, and the same is true for the next two. If you have a participant that does not have a match, then that participant is then discarded. Okay, that will make your job a lot easier. Here's another example. This is where I'm gonna show the problem with matching sometimes. Say you have six participants and you want to match them on characteristics such as sex and educational attainment. So for participant one is female and she finished high school. Participant two is male and he finished college, so on and so forth. Right? So what we do now is we try to match the participants and then toss coin to decide which one is going to go to the control group and which one is going to go to the experimental group. So participant 1 is most likely going to be matched with, so participant 1 is female and high school graduate. So participant 1 will most likely be paired with participant 3. Okay? And then participant 2, who's male and who's a college graduate, most likely be paired with participant 5, who's also male and a college graduate. Okay? Now, we have participant 4, who's a female and is a college graduate. And then we have participant 6, who's male and who's a high school graduate. So that is the question now. Okay, so we have 1 F and then high school. And then you have 3, who's also female and who's a high school graduate. Then you have 2, who's male and who's a college graduate. And then you have 5, who's male and who's a college graduate. But then, what are you going to do with the other participant? So participant 4 is female and is a college graduate, and participant 6 is male and is a high school graduate. So in that case, if you really want to match them, then you'd have to discard those participants. But in some cases, even with that matching, there is still what we call under matching, when you can't really approximate the right combination where everyone in both groups is actually paired. So in those cases, even in matching, there is still a slight problem.